Hey guys, Miss Glover here. So your first lecture today is on measurements that we're going to use in physics throughout the school year. So what we're looking at with measurements is just what units we're going to be using all semester long. So the three main SI units for physics are the meter, the kilogram, and the second. You do need to memorize these. We'll be adding a whole bunch more throughout the year, but these are the basic ones that we're going to start with. So we use the SI system. You've seen that, heard that from all your other science classes before. Yes, we're one of only a couple of countries still that use English units, but the entire rest of the world pretty much uses SI units. So we're going to use all those SI units here in class, so you're never going to measure anything in inches or feet or miles. You're never going to see pounds. So just make sure that you're always using the SI units as we go through it. So length is always measured in meters. Mass is always measured in kilograms. Mass is the only one that has that prefix in front because a gram is so small. Our numbers would just become really big, so that's why we use the kilogram instead of a gram. And then time is always going to be measured in seconds. So here's a list of the metric prefixes that you're going to see. So in front of meter, in front of gram, in front of Newton, we can put any of these prefixes underneath them. You are going to want to memorize this chart. So what you need to memorize is this prefix. So mega, kilo, centi, milli, micro, nano. The 10 factor, and then this symbol. So knowing that mega is capital M, kilo is lowercase k, 10 to the third. Centi, 10 to the negative 2, represented by a lowercase c. If you think about cents, there's 100 cents in a dollar, so 100 centimeters in a meter. Milli, lowercase m, 10 to the negative third. Micro, which we'll use a lot when we get into our electrostatics unit later on in the year. And then nano we'll use when we get into light. So right now the main ones that you want to focus on are mega through milli. Mega, killi, centi, milli. On a test, a quiz, you will just be expected to be able to convert those. We're never going to give you those values. Okay, so make sure that you look at those, memorize them, so that way you're ready to use them on a question. Alright, so the next thing that we have to look at with our units is converting from metric or from English units to metric. We don't do this a lot, but it is a skill that you should know how to do. Those of you that have had chemistry, I know they use the factor label method. So you're used to using dimensional analysis. We want to see you use the same thing in physics. It's just a good way to show your work. So if I want to convert 65 miles per hour to feet per second, okay, or then later on to meters per second, so I'm going from miles per hour into that metric unit, our SI units of meters per second. So I have 65 miles per hour. Okay, no, I don't expect you to memorize your English to metric conversions. We will give you those. Okay, so the next thing you're going to want to do is get rid of that time factor. So I know that 1 hour is equal to 60 minutes, so you'll notice that hours are on top, minutes are on the bottom, so that way your hours can cancel out. And then I know that there's 60 seconds in 1 minute. Again, whatever goes on the bottom, the next one goes on the top, so it can cancel out. And then if you look at seconds, seconds ends up being in the denominator, which is what you want since you're going to feet per second. Then you have to convert the miles. Okay, so 1 mile is 5,280 feet. So again, your miles are going to cancel out. Miles is in the numerator over here, so that means over here it has to be in the denominator. Multiply across the top, multiply across the bottom, and then divide top divided by bottom. Be careful about a common mistake I'll see is that when you have all these numbers in the denominator, make sure you use your parentheses correctly in your calculator. So you get 95 feet per second. Then, to convert that to meters per second, I just have to worry about converting the feet. Again, 1 meter is 3.281 feet. Again, this meter to feet conversion is not something you're going to have to memorize. You do have to memorize your hour to seconds, but y'all know that. You've been doing that for a while. So again, feet has to go, since it's in the numerator, it goes in the denominator. Multiply across top, multiply across bottom, and you end up with 29 meters per second. Okay, so this is just what we're going to want to see whenever you're doing conversions. We want to see your work. Okay, I trust that y'all can use the calculator by now, so really what I want to see is your work. Don't skip steps. Okay, so in every single problem, you don't have to write this slide down. We call this the guess method. You'll see a lot more about this throughout the year, and when we start working problems, you'll see even more about it. So what we use is something called the guess method. So whenever we work a word problem in physics, the first thing that you're going to do is always writing down your givens. So what are they physically telling you from the problem? Any constants that you know, so like gravity, always going to be a given. Then you're going to write down your unknown. So in this case, we're solving for delta S. So I need to see what are you solving for. Okay, then I'm going to see the correct formula. This is the original equation that I give you. So I need to see what formula are you using. You are going to have to memorize your equations in pre-AP physics, something that we do. Then I want to see you solve it for the variable that you're looking for. So I need to physically see the algebra with no numbers first. So I'm going to take this equation, V equals delta S over T. I'm going to solve it for delta S since that's my own unknown. And then I'm going to write delta S equals VT. Finally, I will plug in my numbers. I don't care if you use it with the units. If it helps you to use the units all the time, go ahead, so that way you just know your answers, correct units, or you can just memorize, whichever way. And then finally your answer with the correct unit that you're looking at. So again, you'll see a lot more about this as we go through the year. Okay, so why are units important? Why did we go through this little PowerPoint? In 1999, NASA lost a $125 million Mars orbiter because half the project was done in English units and the other half used metric. So what they did is in December of 1998, they launched an orbiter, okay, to go to Mars. To land on Mars, going to do some exploration. So they launched it in December, and then they lost it in the following September. So 10 months it took to get to Mars. Obviously, it's a really far distance away, so it took a long time to get there. And when they went to try and land it on Mars, the units were off. So what happened is that the company that NASA was working with is based here in the U.S., so they did everything in pounds. Pounds second, so looking at how much force was being applied to it to keep it in orbit, to land it, everything was done in pounds. NASA assumed that everything was going to be done in SI units. Even though, yes, it's based in the U.S., NASA works a lot with countries all over the world. Russia, for example, with the space race, so they keep everything in SI units. To give you a reference, 1 pound is about 4.5 newtons, so the calculations were off by about 4.5 times. So either they thought they were applying 4.5 times more pressure or more force, 4.5 times less force, and basically it was lost completely into outer space, never found again. So $125 million lost into space because of a unit error. Okay, so that's just something to keep in mind. Just check your units all the time. Make sure we are always using SI units. Okay, last thing I want you to do for this PowerPoint is I want y'all to get in groups. So I'll groups at your table, and you're going to take a marble, a block, a ball, and you're going to perform these different things. And I just want you to group them in terms of their motion, however you want. So just find things that are common in how they move based on what you and your group think. Okay, there's not like a right or wrong answer to this. So I just want you to do it, those 8 different things. You can physically do them at your table, and then group just at your table, just talk about what things are alike. So what would you group together? What would you not group together? things like that. So go ahead and perform that experiment, and then we'll talk about it, and then that will move on to the next part of the lesson.